and be lost. They now pump the liquid helium into the magnet. It's one of the coldest things on the planet, and the fill nozzles turn frosty. Exposed to this extreme cold, the magnet loses all electrical resistance and becomes a superconductor, generating intense magnetic fields. With the MRI magnet complete, they move on to the gradient coil, which will control the orientation of the image with electrical pulses. It starts with a fiberglass epoxy tube cut to the correct length. A worker carves grooves in the tube and fills those grooves with epoxy. He then winds copper wire into the epoxy-filled grooves, and it adheres, forming the gradient coil. The team slathers epoxy onto the entire tube. The epoxy seals the wire, preventing vibrations of the coil when it's in operation. They layer etched copper plates onto the epoxy and they adhere. They wrap the coil tightly with Teflon cloth. A worker pours epoxy resin onto the fabric. He then winds tubing around the gradient coil and it adheres to the epoxy-coated cloth. These are cooling lines. They'll disperse heat generated by the gradient coil. Another worker now preps the next fiberglass tube. This one is for the MRI's radio frequency coil.
We're back.